Hello, everyone. Shall we start?
Yes.
Yes.
Yeah.
Okay.
So, welcome everyone for this session. Let's have a quick recap. Anyone can tell us what we discussed in the last class so that we can have a clear indication what we have done so far, and then I'll start from where we left in the last class. Yeah.
Yeah, we were talking about data collection, primary and secondary sources.
Yeah. Yes. What was there in the primary?
Where we directly go and collect the data, like
Hmm.
sampling, we go to an institute and collect the data, or we directly do our own research and collect our data.
Yes.
And secondary
Just for your
yes, we get it from other sources.
Hmm.
We refer to other sources to get the data. That is secondary.
Yeah. So just to have a quick recall, we discussed in the last session about there are 6 main methods for the primary data collection: interviews, questionnaire, observation, experiment, focus group, local sources. And we discuss in very details all those particular aspects, like pros and cons of each and every aspect of the primary data. But yes, primary is expensive in the sense that it will require more time. But where it comes to the secondary, we talk about there are already published sources, unpublished sources. Of course, there are some books, research papers. So you can get someone already had done the enough study, investigation, and then we are just use that as a secondary way of manner of using that data. So we don't have to go again and do the reinvent the wheel. We don't have to do that. Instead, we will be using some of the observations made by the previous primary users who have collected the data. So these are readily available. Of course, this is you can try and get the data and do the analysis immediately. But then comes the cost effective nature of it. Like it is often very low cost because you don't have to spend money and do the data collection, because data collection is a tedious task. I told you it requires a lot of manpower, and for that we have to spend a lot of money for spending on the data collection. So it's a cost effective and it saves times and resources, because now you can spend time in the analyzing the data. But of course that the origin source and the published sources may be different, in the sense that you have to believe on the published sources. But yes, you so in that case, what we do is like we have to believe on the published sources more than on the unpublished sources, which we also discussed in the last session. If you remember that there are unpublished sources, unpublished records, where you can get the data, but then again you have to do again some certain amount of time. Again, you have to spend on, in this case, to make sure and validate the data. Validation, I mean that you have to double sure that the dates, the data, the numbers, the values put are correct. So because it is not published in the government source or government records. Then comes the letters, then comes the personal documents, research reports, surveys. There you can get a lot of unpublished sources. Now, this is the summary. First-hand information from the primary, current and relevant, because it is directly from the origin. High accurately and quality control, it's there because you can get the quality data, because that is the from the origin source you are getting the data. Whereas comes the secondary, it's already collected by some other persons, and they you not need not to have to spend full energy in reinventing the wheel, or you can say that to redo the same task. And it's a readily available and accessible, cost effective and time saving. That's true. Now, transition to data cleansing. I already talked about that. Of course, there is a lot of we have discussed this in more detail about the data collection. That the step one is over now. Step two was to prepare the data in a form which is more readily usable. Readily usable, I mean here is that some of the some of the data may have some missing components. I told you in the last class also that, for example, census data. Census data has certain uh, information which are not been filled. I took an example of below poverty and above poverty line, if you remember that. Those data in terms of property, if you remember gold, I think you talked about the gold X, the how much gold you have. If those information are not been filled, what you will do in that case, because your analysis will not be complete unless your all the columns are complete. So that's what I meant is like the data cleansing means you need to prepare the data in the or the filling the missing details. Then comes the analysis, which is making decision making. This help you to support the decision making, the conclusion which you will draw from the data. And so in a way, that when we do transition from data collection to data cleansing, we ensure that we will have more accurately, precisely, we will be doing the analysis of the data, and it is also making sure that it is those results and analysis should be published to the for the wider usage, because people will start analyzing from your analysis. Means it's a second analysis can be done, like what you have done an analysis, they may try to do something new on top of those analysis. So that means that your reliability on your analysis has to be absolutely spot on, because it should not have any kind of errors, because many analysis can be done on top of your analysis. So let's talk about the more details about the data cleansing. For instance here, I'm talking about like you may have a missing data, duplicate. Sometimes it happens that you may see some columns or some rows have same information as already been there in the previous rows. Then what you will do? You have to cleansing the data in the form that you can remove those duplicates entries, and irrelevant information also is not required. For example, I told you, if you remember I think Bakchi asked this question in the last class, that if I have to not inform the gold one, I said if you have not informed the gold one, but your annual income has already been informed, then the gold information is a redundant information. It's irrelevant to the best of my knowledge, because you can remove that context, because you have already make a decision based on one of the important aspect is your annual income. Then why do you need gold information to be asked? Can I remove that column from the questionnaire, or you can say from the information to be asked from the subjects? So can we remove the irrelevant information? And it's true that we can remove that, and unless that is not creating any kind of change in the outcome, you can remove that column. For example, I told you the gold information is being asked while while the census data is being recorded, in order to get to know that how many how many population are above the poverty and below the poverty line. So that could be one way of thinking of it. Now, you can also have certain errors. For example, I'll tell you a real example of noisy data. Have you seen that EG machine or ECG machine? Anyone?
Yes.
Yeah. What happened there?
It
It records the signals
records.
of heartbeats.
Yeah.
Record the signals, correct, and it records your this one, um,
It
your
records the
heartbeats.
rate of heart.
Sorry.
It records the rate of heartbeats.
Absolutely. So it records the rate of heartbeat and how fast is your heart rate is, and how slow is it, and every kind of PQRST information is being recorded in the cardiac. Correct. So ECG is being meant for that purpose. Now let's suppose sometimes your electrodes are not being placed properly. It happens that many a times that more often than not your recorded data may have noise in it, and that particular noise is predominantly seen every time. If you have seen this or not.
I've heard about it, but never seen it as such.
Okay, you just go once ever, whenever you have get a chance, just see that recordings. You will see a lot of spikes, and
Yes.
those spikes are not the actual the cardiac information you are getting, or the your heartbeat information. Those are like noise in it. Why I'm taking this example, because this is very common with these electrodes. Like the same way with the EEG, if you put on a scalp and then put on the scalp, you put a lot of electrodes, you get the brain signals. Have you seen that? Brain signal information to know what is going in their mind. If someone is a stroke patient and he's not been able to communicate, so with a brain signal we can communicate what he's trying to speak, or what does he imagination. For example, if I imagine an apple, then my brain signal will corresponds with the different than if I imagine a banana. So it is a different imagination signals, so I can easily map it to the actual ones. So the point I'm trying to say here is that those data, more often than not, they are comes with a noise, because you cannot have a kind of a person who will sit quietly and very calmly is taking the observations. You will see some movements of the brain, some the body, and that means that electrodes can provide you some kind of noise in the data or artifacts. So this is one exactly the same way we can have in the real time data, that when you do the analysis on top of it. So what you need to do, you need to have a method is strong enough or robust enough to handle this kind of noise or errors which have been obtained via observation. In that case, your noisy data may be one of the challenge for you to do the data cleansing. So I hope you understand my point, why I'm trying to say all this aspect of the noisy data, because it is very often then you will get the noisy data. And another kind of problem or challenge you will see is incomplete, which I told you. The census data, most often you will see that it is incomplete, and then you will not able to know the what should I fill in those information. Then you try to do interpolation. What do you mean by interpolation? For example, if I have let me put this way. Interpolation is something like if I have a line here, and if I know this is 1 comma 2, okay, this is 1 comma 2, and this is 2 comma 6, and I don't know information in between. What I will be do? What I will do now? Please tell me.
We will find out the mean probably.
Absolutely, we can get one value between. Is the interpolation value could be a mean,
Mhm.
which is your middle point, correct, or median.
Yeah.
So this could be one aspect to it, that this is your mean, and another could be if I do alpha of this and 1 minus alpha of this and sum it, then based on a different value of alpha, I will get different values in between. Are you able to get my point? For example,
S-
I, I'll take an example.
we will assume based on a calculation.
Yes, let's say alpha of 1 comma 2 plus plus 1 minus alpha of 2 comma 6. Okay. Now, if I put alpha 0, tell me what happened. I will be completely here. Yes.
Yes.
If I put alpha 1, I will be completely here.
Hmm.
See, the value of alpha can play a very important role. It can give you all the values in between. This is the process known as interpolation. This is another data analytics data analytical technique which talks about how to fill those incomplete information. Are you able to understand my point? See, mean, median is okay. You can get the median value, but those are only single value. But if I want this value, if I want this value, then how do you make sure that you are close to 2.6 or you are close to 1 comma 2? For that, you need to do something like this. Alpha of 1 comma 2 plus 1 minus alpha of 2 comma 6 means the two extreme points. You do alpha and 1 minus alpha and then sum it. And based on the alpha values, you can get all those in between values. This is a very, very important topic or important concept known as interpolation. Do you have any question on this? This is little bit maths, but it is very important.
What is the difference between interpolation and extrapolation?
See, extrapolation means I'm making move away from these points.
Okay.
And interpolation means I am within that point. interpolate within the two extreme points. Extrapolation means I am extending from here. I am extending from this end, both the ends. Are you getting my point?
Yeah, but why is interpolation important? Because we know that the data will be somewhere between these.
Sorry, say it again, please.
Yep. So we know that in case of interpolation, the data that we are calculating should be in between these two datas. Okay, so we know that it will be in between that range. So why is
You see, just the name suggests, interpolate means something missing in between. Just Google it, you will see that. Interpolate. It is very straightforward. You people are expert in this. You're finding out the meaning of some certain words. So you try and see that. Interpolate. I'm trying to interpolate between the two ends within that. But if you want to do the extrapolation, you are going beyond that the points which are outside that point. So you try to do extrapolation. I'm not trying to do that because my information is something like that. For example, census data. This is filled one. This is filled one. But this is not filled. What you will do? You understand my point?
yes,
sorry.
yes. Yeah.
Yeah. So that's the ultimate point, that missing information is being filled by the interpolation. Okay. Yeah. Any other doubts you have? Please ask. Okay, inconsistent also. Sometimes your data format may vary. For example, you try to extract in .png, but your thing works in JPG. So how do you do that? So inconsistency can happen in that case. Okay. Next. So why data cleansing is important? Because we are trying to make it accurately. We are trying to try to see the importance of this in the form of accuracy. Ensure the data is accurate and reliable so that we are able to see. I told you before also this point, that when you do the analysis, it's not like that it is a first time and end time. Many other analysis will be done on top of it. For example, your analysis can be taken up further and then try to get some more analysis insight which has been missed by you, or you may have a different opinion. They may have a different opinion based on the data. So those things are very important. If your accuracy has been done on the ensure the data is accurate. So that's what I have seen in this case, that accuracy is very, very important when you do the data cleansing. So it's make your things accurate. Then comes the consistency, because when you have data cleansing, then all the data is in the same format. Then you will you can rely on the data, and then you can play around with the data with the same format it is. But sometimes it is not possible. That, for example, there's a .bin file and some other is .text file. What you will do? Part of the data is accessible, part of the data is not accessible. So then it is inconsistent, because you cannot do and one more important point, you cannot throw the data, because data itself is very precious. Already it has been put a lot of efforts to get the data. You cannot throw, but what you need to do, make it consistent in the form so that it is readily accessible and it is consistent with all the data which you have available with you. It should not be like that some other sources provide you in .bin, some sources provide you in .exe. So you try to make it consistent for all. Okay. Third, data cleansing is important because it helps you to remove errors and inconsistency, which I already talked about. So if you do all this, then your interpretability is enhanced. What does it mean? Your information is much more richer than the original form. So data cleansing helps you to make the right format presentable, and also it will be enhancing the representation, enhancing your you can reliability also. For example, if your interpretability of the results are correct, then people will rely on your results. It should not like that. If people will not rely, and more reliability comes, more citation you will get. Citation in the terms that if you have published some your article, then people will start citing your article many a times, because just like an Einstein, I have done something beautiful work, then everyone is citing Einstein because his results are really reliable and it is accurate, and then only people will cite, and then you will get the more reference in your bags, means people will start referring your work, and hence this has become very important in at least in research domain. Then we have also right actions will also be done. Then you will able to go do the right conclusion from the data. Like for example, if you have done some analysis, then it is accurately acceptable when it is have the right decisions, and right decision depend upon the clean data, not the wrong data. So that's all are related as you look at that way. And yes, clean data are crucial for all the data analytics, like for example, machine learning, artificial intelligence, generative AI, all are relevant and useful only when the data is appropriately correct. Correct? Any doubts so far?
No.
No.
Okay. So what is our goal for data cleansing? Accuracy, to make sure that it should be highly accurate, error-free, consistent, better representation, improve quality, and boost the performance. Obviously, whenever you try to add on some machine learning and some kind of predictive analysis, which I talked about in the very first session, then this will be highly dependent upon the data, because your all the analysis is dependent upon the right set of data. It's something like that. If you have started wrong and you're expecting to move in the right direction, it's not possible, because you started itself in a wrong direction, and don't expect that you will be in the right path. So you have to be right at the beginning itself. That's why it is said to be that when the it's a right proverb also, that when the kids are growing, so their right direction should be provided at that instant. It should not be provided at the very last when they have already moved into the wrong path or their habits have become wrong. So that's what it's said to be in this case also, that whenever the data comes in, you should try and cleanse in the data in the beginning itself. It's not like that you should do the cleaning at the later after the analysis. Then it makes no sense, because you have already lost the original like you lot of time in wasting in analysis on the wrong data. So better you should try to boost the performance by cleaning the data in the beginning itself, because it will help the model performance. Okay. Then comes the what are the steps? Remove unwanted observations. I told you there are multiple columns, or you will see the rows where you have to eliminate the duplicates. Have you seen any data which have duplicacies there in the, and you have come across any kind of the data which has lot of irrelevant entries, or you can say the data is not required but still some columns have been put up? Any example you have, any case, any place where you have seen that in your day-to-day workplace or any day-to-day life? Yep, please.
Yeah, we get data at times which is unrequired. So yeah, we have to remove it in our day-to-day work.
Any example, any particular example where you have seen that?
Yes, sir. I have one example. I have
Yeah.
one data set in which the
Yeah.
customer information is given.
Huh.
The names of the customer, all the customers are there, and one extra column is there which indicates female and male. The gender category was there, and also prefix column was there, which indicates Miss and Mr. So I think these two columns make a redundancy, because either
Yes.
already you have given the Mr. or Miss the prefix, so that we can get idea the about the gender. Okay.
The gender, correct.
Uh, and again, they have mentioned the gender column extra, which indicates male and female. So I
Yeah, that
think,
does not require. Yeah.
I think between these two, we can keep only one column. So that's the thing.
Yeah, absolutely right. So that is the right like example you have quoted here. That whenever we already have certain information, the redundant information does not make any sense. So it will add noise to the data. So you have to remove all those redundancies, because unwanted observation may make your model or the performance goes down. So that is what we have seen in our research also. Whenever we have the unwanted data, then like a noise, I told you ECG and EEG data, so you remove the noise first, because once you start working on the noisy data, you will end up in the wrong results. So you have to make it clean it. Okay, fix structural errors also another way, another important point. What does it mean here is that we try to get the right format for the data representation. For example, you get the source, you get the data from, let's say, 10 sources. And for example, I'll tell you very important information. Have you seen this media? Okay, electronic media, correct? There is a text media, there is electronic media, correct? So you have videos, you have audios, you have text. Now all of them are different structures. Like, for example, you are putting your efforts in analyzing the war situation, which is currently around the edge between Iran, Israel, US, Lebanon. Many countries are involved. And you are trying to make a survey and trying to get a kind of a concrete reasons for this war and the prediction on this war and how much devastating it has been, all the analysis you are trying to get on that. But then where are the sources you are getting? One is like video. Obviously, a lot of videos are there related to that. You can see the videos are there of where it shows that drones are coming and then missiles are being blown up and many other videos related to that. Then you have a text media that is from the newspapers. Then you have also audio. You can see the intercepts. Have you seen the intercepts of this? Recently, it is very popular on the social media where there is some kind of interaction is happening between the Strait of Hormuz, where our Indian ships were coming and then the Iran were saying that no, please go back. Something like this is happening. Are you aware of these audio intercepts? I
It's
think
not
this is
available
very
on
common.
social media.
Yeah.
It's there. I
Audio
have seen it from
intercepts.
the. I have heard it from there itself. So I have no other sources. Anyway, those are like audio intercepts also. So now, what is more important here is I get the three different formats. What is this? Text. One is audio, that is MP4, MP3, or you can have something like that. And next is your videos, which is again a different format altogether. Now, what you will do? Do you have answer for this? What
Yeah, there
you
is
will
something
apply?
called fact checking,
Yeah.
which happen nowadays. I am not sure how it works out, but
What?
fact checking. There are fact
Hmm.
checkers, so they give the reliable information. So we will consult those websites or those people who do fact checking.
No, I'm not doing the fact checking. I'm doing the format first. I'm talking about what if you get the from a different format from different sources. What you will do now? Yes. You understand the point now. For example, you are in a data analytics and you're trying to prepare a kind of a survey on the war situation. I gave an example on this. Now, the point is that how do you uh, combine or compile all the information which are in the different format? One is in the text, one is in the MP3, one is in AVI, and then one is in the videos in a different format, PLC or VLC, whatever it is. How do you do that?
Yeah, so the
The
basic idea is to get the right information, right? So we will, consult various sources and try to make sure which is the most reliable source, which I can rely on. And that's the only way.
I'm I'm moved one step ahead. All the sources are reliable. Then even then you have a different format. Then what you will do?
convert them into one single format, like audio
Exactly.
to text.
You have to do some kind of some kind of technology. You have to use it. For example, I'll tell you. You must have heard about ASR, automatic speech recognition. Have you heard this?
Yeah.
Yeah.
No.
Yes.
Have you
Yes.
seen the? It's a Eco. Your Google. This one. Amazon. Alexa. This one. How that works? It takes your voice commands and convert into the text. That is the ASR funda. That is the fundamental principle behind the Alexa is they convert the your voice into text and then text into voice when it revert back your answers. So that is the fundamental objective, that we convert everything into the text. You already have one format, that is a text. Now audios can be converted into the text. That is the transformation you will do. Third one, all the videos can be transformed into the audios, and then audios can be transformed into, and the videos can be transformed into the images, and then images can have certain transcription about those images, that there is a person going. All this can be transcribed. So again, everything can be formed into one format. For example, text, or other way around. You can convert everything into the videos. Now the Gen AI and multiple sources are there, Notebook, LM, and the other things. You just put the text, it will generate the video or audio or corresponding to that. So everything can be convert into one format. That is my ultimate objective was, because you have to fix this different formats. Otherwise, it will be inconsistent. Okay, so that is my point. Then there is also possibility that you will have a lot of outliers. I'm going to talk about in the next session about this, in maybe tomorrow, that how to handle the outliers. So there are interquartile range IQR, which generally we use it to handle the outliers or detect the outliers are there. And there are certain techniques which are meant specifically to handle the outliers, like SVM, support vector machine, which is predominantly used for classification and prediction task. Okay, then handle the gap. Like you can do some kind of interpolation to handle the missing data. You can add the gaps using imputation, deletion, advanced techniques you can apply. I told you interpolation is one important step. Then step two, like the in this step, you can try to do the detection of the outliers, which I already talked about, importing the libraries, checking the duplicates, identity columns. All you can identify this and count the unique values. This is also very important. That, for example, how do you get to know that there are duplicates? For example, if you get the same values again and again, so you count the uniqueness. So that way you can help to remove the duplicates. And outliers, I told you, interquartile range is there, which are predominantly used in their statistical measure to detect the outliers. Then you can validate the data and the format the data, drop the columns which are not important, and all these are very important steps in the data cleansing in the Python. We will take one example in future where I will be trying to tell you what is the different data can be removed and data can be improved or can be cleansed. So the step one is eliminate the duplicate and irrelevant entries. For example, here you can see the Python implementation I have mentioned here. Drop the duplicate rows. So here is the data which you have captured in PDF. Okay, data file. Now in the data file, you want to, this is an inbuilt code, drop duplicate. This command will help to remove all those duplicates. See, you will see in the rows. Similarly, in the columns, if you want to do, it is df.drop, and within that you will have to tell the column which columns you want to find the duplicacy. Like for example, column 1 and column 2, you want to check there is some duplicacy. So there, this command can be used. Okay, now if you want to find the drop the rows with the missing values, so this is the command you can use to remove those rows which have the missing values. This is like very straightforward to remove those unwanted observations. Like for example, I want to remove some of the rows or columns which are missed out or something have a missing values. Okay, so this way Python implementation is very useful in this case to remove those unwanted information. Any doubts so far? Okay.
No.
Now, fix the structural errors. Again, some Python implementation has been done. For example, I told you the text to be the numbers I want to convert, fix the data formats, standardize the categorical data. For example, categorical data, I told you it is like true or false. Now, how do you represent that into numbers? Any example? Just I say that I want to I got the data in the form of categorical that it tells you the dislikes and likes. So likes and dislike. So certain questions were being asked, and then the output is given in the form of like and dislike. Now, how do you convert that into a numbers?
Yeah, we assume it as 0 and 1 and then point.
Absolutely. So those are very straightforward. It's a binary one. But let's say there are three categorical comes in, like, dislike, and none of the above or any.
Yes.
Then what you will do? How you categorize that data or standardize that categorical data?
We do an assumption of numbers
Hmm.
like
Or we
0,
put a
1, and
condition.
2.
You can 1 and 2, absolutely correct. And that none of the above or something like that, you can column
We can
comes, you
Yes, after
map
that.
it to, sorry?
Yeah, after that, true or false.
Uh-huh.
One more in inverted comma. We do that no
Yes.
nil or whatever we want to put.
Yeah, you can put it as a number like something like 0 for not none of the above or any, and
Yeah.
and 1 could be for like, and -1 could be for dislike. You
Yes.
understand my point? Minus
Yeah.
1, 0, 1. So if this is 3 categorical information has been presented. Similarly, this is straightforward because it is a convention you can follow. That if I ever I got this data, I can convert it into the any form, whichever. But you should follow the same convention for all the data. It should not like that. Some of the place you put NA by -10, and some of the places you put NA by 0. Then it is wrong, because you have actually wrong make a misconception or make a convention not followed here, that one thing should be followed every time. Like, for example, if dislike is there, then -1 always. You should not keep -1 changing, -1, -10, -20. You should not do that. You should have only one thing for all. Okay, so that's what one should be careful enough. Okay, now let's see the Python implementation. Convert the column to numeric. This is very important. Any column you have, you want to convert into the numeric, so any numbers you want to convert. So PD to numeric to then df column, comma, errors is equal to course. So these are like certain ways you can convert. PD stands for the pandas. Pandas is meant for the reading the data. So these are ways I will explain in more details in the when I have taken examples. Then convert to data time. Date time. Like, for example, PD to date time, and then df stands for the data file, and then you have to convert that into data column. So all these are possible ways to fix the structural errors. So how do you manage the outliers? So here, this is again use the box to visualize the how to handle the extreme values, or maybe you can see the skewness. For example, I plot a data something like this. So this is a standard Gaussian curve. Have you seen this? Correct. Now, if I plot something like this is right skewness. This is left skewness. If the data has been skewed towards the left, in the here it is data is skewed towards the right, and this is a normal Gaussian curve. So there is no skewness. Skewness generally corresponds how your data has been plotted or it has been visualized. If the data has certain outliers present in the data, you can see from the skewness. So that is how you can represent the outliers. Okay, then you can use the box plot visualization to identify the skewness and outliers, and then you will calculate the mean. which is plus minus 2 into standard deviation, mean minus plus minus 2. Then when anything which is outside this range, it comes in the category of outliers. So if this is the scale which talks about whether any data which lies outside this scale, plus minus 2 into standard deviation with a mean, it will give you the range of the minimum and to maximum. If anything beyond that exists, then it is said to be outlier. Then how do we remove the outlier? We can talk about the we can remove those data which does not come in this range. We can throw them, we can remove them. Okay, so this is how we have, and there is a lower, you can see this is a filter, lower mean minus 2 standard deviation, upper mean plus 2 standard deviation. If anything beyond that exists, any data, then consider them as an outlier. This is very straightforward.
I would
Yes,
like
please.
to know if Python is the most standardized language used for statistics, or is there any other language which is more comfortable
Python
using?
has actually now taken, like, I would say it has actually overcome all the languages, because one thing which Python brings up is the compatibility with the neural network. So training with GPUs and TensorFlow, PyTorch, all are being compatible with the Python. But if you talk about the C, C++, and other object-oriented, I don't think that has been scaled that much as the Python has. And in the context that they are unstructured one. So there is no structure to be there. So that is again a beauty of the Python has come in the recent time, that it has now compatible with almost all the, you can say, neural network libraries. All the inbuilt libraries are associated with the Python. You will not see that in the C and C++. You have to develop a simple code, even a swapping code. If I have to swap between the two numbers, A and B, A is 4, B is 6, then you have to write the code for that. But here in the Python, you have all the libraries associated. You don't have to put much of an effort or emphasis on that. More importantly, you have to just see the structure. You have to see the flow of your algorithm. That is what you are mainly focused on. All the inbuilt things are already there. All the related neural network libraries are associated with Python. So you are lucky to have the Python in the recent time, because it becomes now, like I would say, cup of tea for everyone. So I hope you understand my point, that why Python has been so much focused now. And it's a user friendly. And another reason is that it is open source. That is another added advantage. You don't have to purchase a license. For example, MATLAB. It's a licensed version. You cannot work on the unlicensed softwares or other things. And if you are doing it, it is illegal. So you have to purchase the Python MATLAB for this, and that is expensive. You have to spend a lot of dollars. Whereas the Python is open source. Everyone is using the open source. When it comes as in free, first thing will always be done by this, that people will go for that only. Are you getting my point, I think?
Yes.
Okay.
So it means that in business analysis, wherever, if we get into a domain of business analysis where these data is being stored, or is this data is being used very consistently, we need to know the Python language, if I'm not wrong.
Absolutely.
Okay.
No, I think Python one should go from the day one now.
Okay.
From day one, I would say, not day two also, day one itself.
And how easy or difficult is it to learn this language?
It is very easy, I'll tell you.
Okay.
In fact, I have a plan that if I able to take one exercise on the Python itself in my sessions, where I will be talking about how the Python language has been used to detect the drones. I have one example which I have planned to show you the audio of the drones and then do the detection of the drones with the help of Python itself. So I have one plan for that. So I've collected the data of the drones. some real example. So that's what I've been also planned in the Python itself. So I will show it definitely for you people. Yeah. Okay.
Yeah, thank you.
Yeah. Then comes the handle the missing data. How do you handle the data? So you need to find the null. If there is some null in the some missing value, null means something is zero. So you will have to handle the missing data. Either you can remove it, which is an easy task. But better you should not remove the data. I told you it is very crucial information. So though you have put a lot of efforts, or your primary people have already put a lot of efforts to get the data. So one should always be sympathetic about those data. I should not throw the data. Instead, can we interpolate and get the missing values, which is can be imputed by mean, mode. I told you this is one way of handling the data. If something is missing, try to fit the average value. Are you getting my point? For example, I'll tell you. Let's take one example. Let's say 2, 3, 9, dash, 15. Like, let's say you have got the data and one row was incomplete. Now, how would you do that? Tell me.
So in this case, it's mathematical aptitude, and we try to find out relationship between the previous data
Yes.
and the rest of the data, and try to find out
Yes.
what exactly it will be.
What exactly to be? In this case, I can't see any relation between the previous, though you are right. I can see the pattern. Like this is 1, but this is 6. Then what I should put here? I cannot tell that. But if but your point is absolutely right. If I put 2, 4, dash, 16, 32, then it's straightforward.
It will be 8. Yes.
It will be 8. How? Because you know that.
Square.
2
Yeah.
to the power of 1, 2 to the power of 2, 2 to
Square.
the power of 3. Yeah. 2 to the power of 4, 2 to the power of 5. So there's a pattern you will observe. So then this way are the advanced way of looking at the imputations. Like how do you fill that null or those null places? Here you can actually do one simple task. You can take the average value and fill that. Can you do this?
Yeah.
Put the average.
It becomes 12.
15 plus 9,
24.
24 plus
Yeah, but
3
if I do
plus
so,
2.
the previous information is not matching. Like the average of 2 and 9 cannot be 3.
No, but at least you can fill some number. Instead of removing this column, you can actually fill that number. For example, 2 and 3 plus 5, correct? 5 take an average is not, it is 2.5, but it is 9, correct? I do agree. 9 plus 3 is 12. So again, can you add that something like that? For example, 2 plus 3 is 5. Then add 4 to it. Okay, I'll do the same way. 9 plus 3 plus add 4 to it. It is 16, which is not correct because 15 comes in. So I have to be something in between. So just think that way. The average will be the mostly appropriate in this case. In most of the cases also.
Yeah, any number between these two numbers will be the best option.
Absolutely. But that, what will be the number? You can see that 15 plus 9, 24, plus 3, 27, plus 2, 29, divide by 4. So it will be 4, 7, 28. No, I don't think.
If
Or
we
you
take
can.
average by 5, it will gives 5.8.
But no, don't do that. Do one thing. Just add the average between these two. 15 plus 9. It is 24, then it is 12. Correct?
So rather than accuracy, we will
It's
look for
12.
more appropriate numbers. So instead of choosing accuracy, we will go for more
Hmm.
appropriate.
Yeah.
Is that so?
See, none of the answer will be wrong. I'll tell you why. Because since more important is to fill the data, first of all, because leaving the data itself will give you errors, just like that. So what you do, just think in that way. I'll tell you how to justify this answer. 2 plus 9 is what? 11.
11.
Divided by 2, 5.5.
5.5.
Correct?
Yes.
Yes,
It's close to 3. Fine?
yes, sir.
Now, 3 plus 12.
15.
15 divided by 2,
7.5.
7.5. Close to 9.
Yes, sir.
In that case, this is okay. You got my point?
Yep.
See, you will not get exact fitting. This is nothing but a fitting to the data. Fitting to the data, I have to fill this missing point. But how? That is not going to be exact. Just like in this case. Here you can see the pattern here. But here you can't see the pattern. Once there is
So
no pattern,
if
that, yeah.
so if there are many people working on it, so suppose there is a huge data and somebody is filling in 12, somebody is filling in 11, somebody is filling in something else, and then when we combine the data, it's again creating a confusion. Is that a possibility?
See, it's good point that you have mentioned actually. Having more people involved will always reduce your error less. Average error will be down. Do you know this or not?
Yeah.
Like for example, I did that and then started working on it.
Mhm.
Though this may not be the right answer, I know that, but I fill it and then start working. You do it by yourself with some number, then
Mhm.
you find it. Then next person, let's say you did it by 1,000 people.
Mhm.
Your average error will be goes down. Your variance will be less. More the data, less the variance,
Yep.
less
Yep.
the error. You got my point? What you
Yes.
have said is the right answer actually. You have actually answered the question. If I am the only one single person who is filling it, I have only one chance at, correct? Maybe then I have 10 odd or 20 odd or 50 odd or 1,000 odd people doing the same thing. Obviously, then the average error will be less. I hope you understand my point now. No, is that not make sense?
No, what I was trying to say is that suppose I am working on 1,000 data sets alone.
Okay.
So what I assume on one data set, I will assume the same on the other data set as well.
Correct.
Right. Now, but if there are
No.
1,000 people,
No. I'm sorry. It will not be correct. I'll tell you why. Because you will see some pattern there. For example, what the pattern I followed? Let's say 2 plus 9 by half.
okay.
Then 9 plus 15, half. But there you will not have the same number. You will have a different number filling there. But the pattern would be the same.
No, but this data is very straightforward. What I'm saying is that if the data is complicated and more in the form of categorical data, then if my assumption, if I work on 1,000 data sets alone, then my assumption will be the same on all the data sets because I've already assumed that, okay, this is how it is going to be. But
Correct.
someone else working on it will have a different assumption, may have a different assumption. And if there are
Correct.
1,000 people working on 1,000 data sets, all right, then
it
the
is beautiful.
assumption,
Then your average error will be less.
okay.
Because more the large number of sample, you will reduce that variance. When only 2 people did the task, then obviously the error will be large. When the same task is done by the 10, 15, 20 odd people, then the average error will goes down. This is
Okay,
how
so
the central limit theorem says. When you
okay,
try
so
to,
so what
please
so
tell me.
you're saying that it's not the data, but it's the number of people working on it which makes a difference.
Absolutely.
Okay.
Same data done by all of you.
Okay.
Then the average error will be less. Correct? Okay. So then we also have the implementation
I have
over.
one
Yes, please.
question.
Yes, please.
It's all about data, means related to numbers. What about if some string is missing, like some customer name or city name? How can we
Okay.
handle that missing values, string values?
Oh. See, in that case, I need some more help from you. In the help, I need more information from you. For example, if missing data has been, like for example, name is missed out, correct?
Okay.
You said that the name is missed out in the file and then we could not proceed further. But definitely you must have other information in the form of their pictures. For example, you got the Aadhaar card. Though your name was missed out or spelling is mistake, then you can consult the other information. That is what the my previous discussion was. Like for example, you don't have only one source of information. You have the multiple sources available. For example, you have the text, which is your CSV file, your Excel sheet. Then you have the audio, or you may have the videos where it talks about the person information, correct? Or the images, like you have the photos of that person, the ID card of that person or something like that. You can get those information, correct? So those way you can consult and then revert back and then fill those information, correct?
Okay.
Yeah. So
So, sir, according to you, we
yeah.
have to fill that null information. We cannot keep it as a null only. So anyhow, we
No,
have to input the data
see
over there.
many researchers have a different opinions in this case also. But to the best of my opinion, I would not throw the data. And my funda is very clear because the data is very precious. I would not just because there is some columns are not been there or some columns are not been filled out due to some XYZ reasons. I will not just throw it blindly. I will try to put some efforts to fill that information. Though it will may change your results a little bit here and there, but then it will help you to improve in a future aspect that the way you have learned the pattern of filling those information, maybe for the future task you can get that pattern also, so you can learn that pattern. But if you just throw it out, you will not have any kind of learning there, prediction there. Have you heard about the last time which I talked about? Not the last time, maybe in the very first or the second class, I talk about the predictive learning or predictive analysis. Remember that?
Yes.
Where I tried to learn the trend or the pattern. Then if you do not have the missing data, and if you throw out, where do you learn the pattern then?
No, I'm not saying about
You're-
the showing the data. Suppose I have so rest of the rows completed, only the one column is not there as a null. So in future, may I get the value for that column or that row? But right now, can I put it as a null? Because in future, I'm going to get that value for that null value. Okay. So
Yes.
for right now analysis, can I keep it as a null? That's
Null.
what I'm asking actually.
See.
See, can I give you one example to get clear?
No,
Yes,
sir,
please.
I will give you an example here. Now, suppose what we are calculating is the sales price of a product, like the total amount, right? And
Yes.
the total amount, suppose the price of each product, there's a column which gives the price of each product, and there's a column which gives the number of products. So if we have to find the total amount of sales, we have to multiply these two products, okay, these two columns, and find out the total amount of sales done for each product. Now, in
Correct.
this data, if we have something called a city, so this is irrelevant data. And if we find any null in that city column, then we can just go ahead and omit that data and do the calculation. That's what
But
I
then
think
why don't you cut that complete column if that is redundant? That is
yeah, that's
also I told you. That is
yes,
also I told you. For
Uh,
example, if you have forget this point, I think redundant information,
mhm.
remove. So if you said that that column itself is, let's say, one of the rows of that column comes out to be null, which you want to try to fill. But if that column itself is whole column, it does not make any sense to the outcome. Why don't you throw it out? Then why
Yeah,
do why? But I told that thing also very clearly that don't throw unless it is making an outcome, having some impact on our outcome. But if it does not, then throw it out. Are you getting this point or not?
Yeah.
The lady asked a question. I forget the name. Is that answer your question? Sorry. Who asked
Yes,
that?
sir, but still somewhat
Bhakti.
confusion is there.
Yeah, tell me what is your confusion?
Yeah. So same example what the Niladri had said. We
Yeah.
have a sales data. Okay. So we are having some products, okay, which are completed and which are ongoing. Okay.
Huh.
So for ongoing products, we cannot give the exact amount, the production cost. I'm just saying about the production cost. So suppose some products are ongoing in the manufacturing industry. So we cannot determine the exact what is the product cost of there. So for that instant, that column or that value should be null. Okay. But for completed products, it may have some values. Okay, so how we can apply the null over there, or
No.
what decision can we take
I
for
told
that?
to answer this question. Remember, we talked about the predictions from the patterns.
Yes.
I told you this point before also. For example, you have last 5 years, you are looking at your sales of a particular product. Okay. And this ongoing, you are saying, I will put null. Why? I would say you have the 5 years data. Just try
No,
to do
it's
some
for
kind of
new
predict.
product. Some new products I'm manufacturing this year. So for the first time we are manufacturing some products. So for that case.
For the first time, then what you can do, obviously, then for the first time, it is very new and it has no relation with the previous ones. Then I cannot say anything because it's a very first time. But then you have one thing also, information is that that product also exists with other companies.
Okay.
Does that product exist with other companies? If yes, then you can say the sales there.
Achha. So
You
we
can see
want
the
to
pros and cons of. Sorry. Yeah.
So we want to work on the more on collection of data. So we need to collect the data from all the.
Obviously, I told the basic thing in the beginning itself.
Okay.
Without the sources enough, multiple sources makes the work easy because your error will be less. That's what I told to Niladri also, that let's say I gave that fill information, you have done that 12, someone else come with 11, someone else come with 13, someone else come with 12.5, something like that. Then obviously you have more people involved, you have more sample involved, more sources involved. When you have more sources, of course your results will be more accurate or error will be less. Correct?
Okay, sir.
Yeah.
Got it. Thank you.
Yeah. So then these are like how we include the Python libraries. I will take example, but just to give you an idea. Import means you have to import the library pandas. And I'm saying pandas instead of saying pandas again and again, I would say pd. Similarly, import numpy. Numpy is meant for mathematical operation like addition, subtraction, doing some kind of calculation, some kind of analysis, some statistical analysis, mean, median, all this thing done in numpy. Then you say it is np. Then you read the file. I told you pandas is just for reading the files, that csv, excel, whatever. Then you set the name to it. File.csv is the file which you want to read it. Okay, do one thing. Maybe next time you try these, which is already shared with you. Try to do some hands-on by yourself. I will also do in the next class, but yes, please try by yourself as well. Then you can see the file has been now saved as df. Df stands for data file, which carries all the information, all the columns, all the rows of this file. Now, if you want to see the information, df.if. You want to see the head file of it, df.head. You want to see the shape, how much rows and columns. For example, there are 10 rows and 20 columns. Then what should be the shape of it? 10 cross 20. You can see that by checking the shape of it. So why these libraries? Because Python, I told you, one of the statistical way of handling the data is via the Python. There are Excel, there is CSV, but Now everyone is moved to the Python because Excel and becomes are now obsolete, and many a times you need to do more difficult formulas which you want to like. For example, you want to see the predictions which you want to do, as Bhakti said, I want to do the sale prediction of my new product or my old products. That you can't see on the Excel sheet because there you cannot get that prediction analysis. So prediction, you need some learning to be there. Learning means pattern analysis, pattern recognition. For that, Python is the must. So that's why I'm moving everything on the Python so that you people also get accustomed to start using the Python in future. So why these libraries? Because it will help you to do the data analysis, data manipulation. NumPy, for example, I told you numerical operations, all kind of numerical operation, multiplication, addition. You do some kind of maximum, minimum, and then statistically mean, mode, interquartile, which is there in the Excel. I'm not saying that it is not there, but then predictions are not there in the Excel. How do you predict? Let's say I get the 10 years data, I give you the 10 years rainfall data in the Excel sheet. Can you predict it on that? No. Excel cannot do by themselves. You have to write some code in the Python. And that is why we use Python and then corresponding libraries. Okay. Now, check the duplicates. I told you Python in the DF file, you just put the duplicate as an inbuilt library is there. Duplicated is the library which are, it's there to make your and my life easy because I do not have to write the code for every small task. I told you swapping for two numbers. In C, C++, you have to write the code. There is no such library exist. But in Python, everything is there. Sorting. For example, I ask you this task. 1, 10, 9, 0, 3. I ask you to do the sorting. How will you do that?
By writing code.
Yeah, ascending or
Yeah.
descending, it can be from 0
Yes.
or
Yes, you will do first 0, 1, 3, 9, 10. This is in the ascending order. Similarly, you can do the descending orders, correct?
Mm.
But does Excel sheet provides you this?
Yes, sir.
It's there, correct.
sorting is there, yeah.
Sorting is there, but does it gives you the pattern? For example, if the fill information I want to fill,
No.
that if I gave you something in missing in
Mm.
between,
Yep.
Excel
No.
will not give you that.
Mhm.
Handle the missing data. Does it give you the duplicate? Let's say I give you 3, 3, 1. If this is the data, does Excel give you the duplicacy?
Yes.
Yes, sir. Excel will give.
Okay, because I'm not very much familiar with Excel, but yes, I can use some of the basic stuff, but I've not gone into that detail. But because I'm very much familiar with the Python, because which is much more advanced version to it, and then I prefer Python because I've been putting all my research in Python. So that's why I'm asking you questions that you may feel that sir knows it or not, because I have not been very fond of Excel, to be very honest. But I'm asking from you that duplicacy, if it is there, then it's okay. But then where that pattern recognition comes, you cannot do that writing code there. That is one thing I am very sure about. The Excel does not give you the editor option to write the code there. Does it?
No, it does not. Does not.
No, does not. So I need not to bet on this that Python is better than the Excel. That is always be the case. Okay, though you can still use Excel for the basic things. Okay. Then identify the column types. I told you the column types would be understanding data types, help choose the right analysis and cleaning method. For example, categorical data, you want to see if there is a categorical or if it's a numerical. In the numerical, you will try to use integer floats. In the categorical, you will try to use the objects, strings, so that you will print those information of those column types, like what kind of data type it is. So example, I'll tell you one more important thing. Another useful component of Python, I'll tell you. Does Excel give this information? Again, I'm asking because I do not know it in the Excel, whether it's happened in the Excel or not. You tell me, because you people are very much familiar with the Excel. Though I use it, again, I'm not saying that I've not used it. But again, that much I have not used than the Python. Okay, I'll ask this question. If I gave you the data, which is multiple data formats is there. For example, I say she is 10-year-old when she was 1996. It has both the data. What kind of data? Can you tell me? What kind of
Text
data
and
is this?
numbers.
It has both. What? It
Text and
has
numbers.
text,
I
numbers,
mean, here date and numbers.
date, numbers, and also it can have something like text also is there, numbers also there. It is combined actually. Does Excel give you that it is a categorical data or it's a numerical data? My question is this to you. Again, I'm not demeaning anything from the Excel. Don't take it otherwise. I'm just telling you that there are certain advantages which I want to tell you why Python becomes so important these days. At least for the data analytics and business analytics. That's for sure.
Yes, sir. When we transform the data in that, we have the numerical data option replace into the text data.
Where? In the Excel sheet?
When we do the editing part, when we load the data and transform the data at that
in PQE mode, Power Query Editor.
editor,
Right.
yes.
Okay. In the Excel, it is possible, correct?
Yes,
Yes.
sir.
How user friendly it is? Hello? How it is easy for a new person to understand?
No, it's little
Not
much
that easy,
difficult.
sir.
So
It
I
requires
assume
special
that,
knowledge.
yeah. So when you need some special learning, why don't you put that special learning in the new things, which is much more relevant in the current context, correct?
Yes.
So I will bet in that case. See, I will convince you in this fashion that when you have to learn a new thing, then why don't you go for this Python itself, correct? So that's where you can see the column types are also being clearly categorized. You can see the separate categorical column for column in df column. If df column is d type is equal to object. If the object is there, then you say it's a categorical. Then you check within that. You see that this is so easy that within the checking itself, within the if and else statement, you can do that column for column in df columns. If df column dot d type is not equal to object, then you put it as a numerical. If this is means not equal. So all this can easily be printed out. You can easily do that. And all the tasks can be done in a Python itself. Anyway. Then count unique values. I told you number of times you will see the duplicacy in the data. Then what you do, you will see n unique. There is in the categorical data, once you have already obtained, you just check n unique. Count unique values per column. Number of unique columns. So you will get the number there. There are, let's say out of 10, only 5 you get. What does it mean? If out of 10 columns, you got 5 df dot n unique, get you 5 number. What do you mean by that? Yeah, it's straightforward. Out of 10 columns, how many columns are unique? Only
5 columns are
5.
unique.
5 columns are unique. And that's way you can also put it in the rows also. Just like you have put it for columns, you can do it for the rows as well. Similarly, you can do it for all the data. So this can help you to check the data imbalance in the data. For example, one example I told you that I want to categorize between the male and female from the data. From the census data, I want to categorize. Just think this is a very good example. I just came into my mind. For example, you have an Excel sheet and you want to categorize how many are the male and how many are the female. And you do not have been categorized in the terms, or you do not have been given the column that is as in gender. What has been informed? The what has been informed is something indirectly. It has been informed that it is a male or it's a female. For example, the kind of the habits usually possessed by the males and then females, or kind of activities performed by the males and then females. There are certain places which is be common when we are leaving about those things, but we are making it very clear distinction between those habits. Now I'm giving you those information, I'm telling you, but from that, can you categorize it? The which one is the male, which one is the female? This means that you have to detect from the data itself. But let's suppose if there are 20 columns or 20 rows in that 20, I'll explain like this. Just let me put this in way. Okay, column 1, column 2, column 3. Okay, these are the features. These are my features. FE I'm writing. Okay. And I'm writing for the rows 1, 2, 3, 4. Likewise, I have till let's say 20 odd samples I got. Based on 1, 2, 3, I have to categorize this is a male or female. And 1, 2, 3 are the habits or could be the choices of their preferences for the eating or kind of colors. The choice of colors usually have the males and females. I'm just putting likewise. Okay. Based on this, I'll tell you you have to you have to identify the pattern that this, let's say this is 1, this is 2. Likewise, you have 20 samples. Out of these 20, how many are male and how many are female? Are you getting my question first?
Yes, sir. How
Question
to
is again
identify the male and female
from 20
without
based
their
on the
genders?
feature, without telling inform the genders. Absolutely. Just inform 1, 2, 3 features, their choice of colors, choice of habits, and or choice for driving also very particularly. I'm not discriminating anything, but the choice of females driving is different, or cars, or maybe the two-wheelers or four-wheelers, or choice is different. Okay, so I'm just putting a random example. Don't take it otherwise. Okay, it's a random example. Based on these choices of 1, 2, 3, you have to categorize out of 20 how many are the males and females. But one more thing I have put it that there are certain not uniqueness in the data. Means some columns are some rows are repetition. There is repetition there. Are you getting my point? Out of 20, there are certain repetitions also. Now, what you will do? First thing. First thing, what you will do? You have
Removing
20
the
samples.
duplicates.
Sorry, Meghna.
Sorry,
Yeah.
removing the duplicates.
Remove the duplicates. First thing is very good. You will remove the duplicate to have a unique values, correct? Unique thing, you will keep it. Okay. What you will, after removing the duplicates, you got only, let's say 5. Only 5 unique values you get. Now, in 5 also, you observe when you do the now distinction based on these features, you found that 1 and 4, let's say 4 are the males M and 1 is female F. But did you see that after reducing the duplicates, your data is become imbalanced? You have more on the male side, more on the less on the female side. Yes or not?
Yes, sir.
Then what you will do? When you want to prediction, when you have this as in data now, after prediction, you got this one. Then you see that there is some kind of imbalance in the data. After uniqueness is gone, after remove the duplicacy. So after making it unique. So this also a purpose of our study as in data analytics, that we have to detect is there any kind of imbalance present in the data. Imbalance means the two categories, male, female, should be equal number of samples. But if it is not, then you have to make the balance between them before you go for the prediction. Prediction in the sense that when you go for the identification for the new data, as someone asked, Bhakti asked that I have the sale prediction, but if there are many of them are not a unique inputs, there are many repetition, then you cannot do the prediction on the unique non-unique thing, because then it is always be biased, because this one. Okay, are you getting my question clear?
Yes, sir.
Okay, let's move to the next point. Missing values, I already talked about that. If there are some null, you can either fill with some kind of strategy. And strategy, I told you, it can be plan imputation strategy, could be mean value, median value, or more importantly, interpolation. Interpolation could be alpha of some value plus 1 minus alpha of another, and in between you can find those interpolation. Okay, so likewise you can do and there is a code also mentioned here. So you can try this at your place for this some examples. Then drop irrelevant columns, which I told you, the redundant information which does not make any significance to the outcome. You can drop them, df.drop. For that, you can see the columns which are drop the specific columns, column 1 and column 2, and you can drop from you can use the inbuilt code which is drop. And df drop na means drop the rows with the missing values, subset from the column. You can, from the particular columns, if you find there are certain rows which are missed out, you can throw them out with this. Yes, please. Any doubts? Any Bhakti?
Yes, sir. Sir, do we get some questions? I mean, in exams, are we expecting these codes, the Python codes?
Do you want that? Precisely, it will be more difficult, I believe, for you to do that.
No,
If
I'm
you want,
asking if you want to appear for the exams, such questions will be there on Python code. I'm asking like that.
No, that's what I want from you. You want the Python, I can add it. If you don't want, I will not add it.
It will be better, sir, if you skip.
I will skip that. No problem. Because it is new for you, correct? All of you?
It's completely new for us. That's why.
No problem. I will not put that in the Python. Okay, fine.
And when we will do this Python course,
Yeah.
I think in
Yeah.
that we will find all these.
Absolutely.
Okay.
Which all. In fact, if you want, I can take one session on Python in the next session if you want.
Okay.
All these things
Yes,
can.
sir. That will be really
It will be-
beneficial for us.
Yeah, I will do that.
Huh.
Okay, fine. So detect outliers. You can also have some statistical methods to detect there is some kind of outlier. So what do you mean by outliers, by the way? I've been talking about outliers many times, but how do you identify the outliers?
Which is out of our range, which we are looking for.
No. It's not like that. Anyone else? Outlier means the behavior. You can talk in the context of behavior. For example, behavior of your rest of the group and behavior of certain people, few peoples in that group are significantly different. It happens many a times. You see in the society also, there are certain people who are very temperamental. They they get angry very early, so they do not gel with the society, and they do not mix it up so easily. So they are mainly are, I won't say that they are outliers, but I would say that they have a different behavior. They are different in the context of their understanding towards the topics are very different. Their intake and outtake is completely different, I would say. Okay, so similarly it goes with the data.
When the consistency of some numbers breaks and there is one odd, there is a more gap, I think that is comes
Yes.
under the outliers.
Yes. For example, I'll explain within a figure here. So I'll explain like if your all the data lies in this, then it is said to be no outlier because it is okay. But when you have something like these, now here its behavior is somewhat acceptable. But once it goes beyond this range, it start having a different mean, median behavior and statistical values, interquartile range, completely different actually. They do not behave as if they were usual behavior. So all this are like having very much different, you can say, their statistical values. So those are like said to be outline. Yes, please.
So, by seeing the data only, we can identify the outliers, or we need to put the graph, right?
You can't see the
Sometimes-
data. You have to plot the data first.
Okay.
Why? Because how do you get to know that it's -5 is outlier
Yeah.
if -1 is also there? But when you see it's both the dimension. Dimension means it's input or output values relation. Like when X is there, what is Y? When X is this, what is Y? So when you see
But
that,
if we see
okay.
the range of the data,
Uh-huh.
then I think we can find.
Yes, you're right. The range is the right answer. Like for example, I told you the previous slides, mean minus plus twice of the standard deviation. If you see that mean minus standard deviation and mean plus standard deviation, if the range if the data lies within this range, then it is having normal behavior. If the data lies above this range or beyond this range, then it is outline. Correct?
Outline. Yeah.
Yes.
Thank you.
Okay, so can we take 2 minutes break? Yeah.
Yes, no problem.
Yeah. Just 2 minutes. I'll just drink water and then come. Yeah. Hello, shall we start now? Yeah.
Yes, sir.
Okay. Yeah. So we are almost finishing with this slide because this is very important. Now, Z-score plays a very important role. I told you outlier boundaries. I gave it before also, like when you have outliers, you can check it here. Mean plus minus twice into standard deviation. The lower and the upper range. If anything data lies in, let's take an example. Okay. You know how to calculate the mean, correct? Let's say I have 1, 5, 9, 13. Okay, can you calculate the mean of this? Yeah, it's not that difficult. Mean is 1 plus 5 plus 9 plus 13 divided by 4, correct?
Yeah.
What is the mean?
7.
7. Okay. Well, how you calculate the standard deviation? You calculate the 1 minus 7 whole square plus 5 minus 7 whole square plus 9 minus 7 whole square plus 13 minus 7 whole square plus total divided by 4. Can you do this? And tell me that is your variance, and standard deviation is square root of variance. In next class, I will be talking about this, and then only I will take this Python exercise, because first I have to tell you the basic examples. Yeah. Yeah, please tell me. 1 minus 7 or 7 minus 1, because it's a square, so it is hardly matters. Yeah, what is the answer of the variance, please? I again explain 1 minus 7 whole square plus 5 minus 7, that is 2 ka whole square, which is 4, plus 9 minus 7, again 2 ka whole square, it is 4, 13 minus 7, 6 ka whole square, it is 6 in 36. Then 1 minus 7 is 6 square, 36. Okay, so 36 plus 36 plus 4 divided by 4. Can you please give me the number? You have a calculator, I believe. You can use your phone.
Standard deviation is 4.47.
First, tell me variance, please.
It's 20. 20.
Okay. So you got 1 minus 7 is 6, 36 plus 36 is 72, correct? I'll also calculate 72 plus 5 minus 7 is 2, so square 4 plus 4, 80 divided by 4, it is 20, correct?
Yes.
Yes.
Now what is standard deviation? Put the square root of this. Can you calculate the square root of 20? Approximately 4 point something, correct? So standard deviation will be
4.47.
Yeah, so it is 4.4. Let me put 4.4. Now, can you now find this range, please? Lower and upper. You can expect such question in your exam. Lower is mean minus twice into standard deviation. And check whether your outlier lies in this range or any outlier is there.
Lower is minus
Lower is
1.8.
11.
Lower is
Minus 1.8. Mean minus 2 into standard deviation.
Yes,
Correct.
twice
Minus
is 4 is 8. Yes, minus 1.8 it's. Yeah,
Yes.
correct. And what is about above? 7 plus 4, correct?
15.
7 into 8, 15. So minus 1 to
15.
15. So any outlier you like, you can see in this data. Can you see any outlier is there in this? Yeah.
Mhm.
Yes.
Where? Which one?
No, sir, there is no outlier.
There is no outlier. So this data has no outliers. Are you getting my point? This is very, very straightforward, but yes, you have to calculate the mean and standard deviation. Now tell me, all of you, it's only 2 people I have heard. What about others? Are they active or not? Others are active?
Yes, sir.
So tell me, do you find any number in this which is outlier
No,
or you
sir.
can consider to be outlier? No.
No, sir.
No.
Is it with everyone or only 1 or 2 people are looking at or doing it?
Actually, our data is in between 113, right?
Yes. So this data is lying between this range, which is this one. So no outlier found, correct? Good. So I was trying to say the same thing. How to detect the outlier? You can just calculate this mean and -2 standard deviation. You first calculate the mean from the DF column, calculate dot mean. Mean is again a inbuilt code is there. Again, standard deviation is inbuilt code is there in the Python. Then you calculate the lower, which is mean minus twice into standard deviation upper, and print that boundary. And if you print that, then you will set this boundary limits, you will get to know. And any data which lies within this is set to be no outlier, and any data which is beyond this data, left and right, then it is set to be outlier. Are you getting my point? So this is your Z-score method. Please note down, this is your Z-score. This you will always calculate. How? Calculate the upper boundary, lower boundary, and then you compare. If the data is within that boundary, it is normal. If it is beyond, then it is outlier. Okay, imputation. This means how to fill the missing values. I told you before also, I can do multiple ways. Mean value of the whole data, I can put it somewhere. Median value, mode value, and then I can fill it. And then here you can use the fill NA, which is the code which is widely being used to fill the columns, which are incomplete. The fill with the mean, you can see that. You will fill that only those columns where there is a null by the mean value. Similarly, fill that those columns which is incomplete by the median. Similarly, fill those columns which are incomplete or missing with the help of mode, as you could see, and fill all numeric columns in that case. In case there is completely incomplete, then you can fill the mean there. This is very straightforward. Okay. Then recalculate the outliers. Now, recalculation means you can, this is again the repetition, I would say, because it is calculating the statistical range, which is between the lower and upper one, and lower one is mean minus 2 into standard deviation, and upper one is mean plus 2 into standard deviation. So then you can recalculate the outliers, which is again a repetition, I would say. Yeah. Okay, no, but recalculating outliers is important. Why? You know that why? Because after filling those data, let's suppose I took an example. Let's say what was the number? 5, 9, correct? And dash
13.
13. Let's suppose. If now you have filled this number by mean, 13 plus 9, what is it? 22. 11. Now, can you calculate? This calculation is again done to check that this whole number 1, 5, 9, 11, 13, does it have outliers or not? You understand my point? It will
Yes,
check
sir.
again, recalculate after filling the data, imputing the data. Statistics may have changed and required boundaries can be recalculated is required. Okay, so that is why first you have done with 15913, but now there is another column which was incomplete, which you have thrown previously. Just think like that. But now you have filled it with some mean value. Then you calculate again its the complete mean and the standard deviation and the new range of lower and upper, and then you again find out whether there is an outlier or not. Okay, so this is the process repetition again. This is required because you have filled a new number there. Now data validation. Now here you will ensure the data is accurate, complete, and ready for the analysis. After everything is done, now you have calculated the outlier, you have filled the data, you have removed the redundant files, redundant columns, and you have done all the cleanliness. Now you do the data validation, and validation is done to make sure that you are ready for the analysis. So independent features, target variables, then you do the feature selection and data readiness. And then you do the data formatting. Sometimes it is very important to understand that data format plays a very important. For example, I'll tell you one more example. Let me put 1. Another one is 1 10 to the power of 5. This is 10 to the power. Okay. And next is 20. Can you see what is the range of this data? One is single number 1. Another one is 1 to the power or 10 to the power of 5. Next is 20. Do you see this is okay, this data? Do you see this data is okay?
No.
No.
Why? Why?
Because it has defined format in it.
It is
Like
defined?
it has defined format in these numbers. Like it's showing the power values and the numerical values as well.
No. All is okay. One is one number, one is 1 to the power of 10 to the power of 5, which is 1 lakh. Next is 20. But do you see the range of that? One is 10 to the power of 5, one is 10 to the power of 0. Are you getting my point?
The format of numbers is not proper.
The format is okay, but the range is not, you can see between 0 to 1. Is it or not?
Yes, sir.
Then what you will do? Now how you will make it between 0 to 1? This happens, this if you do not make it normalize this data, what will happen? You will see the maximum range and minimum range has large variation. Can you see this? 1 is 10 to the power of 5 is a maximum value and minimum value is 1, which is 10 to the power of 0. So the range is very large. And when you do with the prediction analysis on such data, even you can have this problem in your data as well, in your case as well, when you see the data variation. One is in the order of 0, one is order of 5, 10 to the power of 5, one is 10 to the power of 2. You cannot work such numbers. You will definitely get overfitting or the results are wrong because you have not taken care of the normalization. So what you will do, divide by the maximum value, 10 to the power of 5. Here also. Then this will be 1. This will be some value between 0 and 1. Very small, but it is at least 0 to 1. You are getting my point? Are you getting that why we need this data formatting? Hello, I can't listen to you people, or you people are now tired or enough for today. I'm just finishing. It's
Can
just
you repeat one, sir?
Yeah, I repeat. I have sorry, I have removed that. I was trying to say that you have the range of this data. Range means maximum and minimum value. When there's a very large range, that you will end up in wrong results always because you have not normalized the data. Normalization means you will put the data always in the range from 0 to 1. But in the previous case, it was between 1 and 10 to the power of 5, which is 1 lakh, which is a very large range. When this happens, you are bound to have some overfitting in the data. and prediction analysis will be wrong. So to solve this problem, what we need is to divide by the maximum value, maximum number. In this case, it was 10 to the power of 5. So it will be having a maximum 1, and then minimum will be between 0, above 0. So that is how you divide that whole range and bring that whole range from 1 to 10 to the power of 5 to 0 to 1. That's how we define it. Okay, so that is the meaning of data formatting.
Okay, sir.
So that is what rescale the value between 0 and 1 so that you can preserve the original shape. And minimum value maps to 0, maximum will be 1. And then you standardize the data x minus mu divided by sigma, and that will centered around the mean. It means that everything is centered around the 0. And the mean is, I want to make my whole data standardized by having the mean is 0 for all with complete data. So this will help my analysis to be good. My complete data is now shifted from a very high mean to 0 and standard deviation to 1. That will always my standardization. That is always useful because now my whole data is centered around my mean. So this step will make sure that your results will be accurate. Always please keep that in mind. You have to do this step. After you have removed the unwanted columns, missing values, you have filled it, you have done all the previous discussion we have done. After that, you please do this one, standardization. Now there are certain tools available which you can be interested in. Open Refine, free open source tool. You can do that for your work. Trifacta, Wrangler, AI powered platform for data cleansing tool. TIBCO Clarity, this is for standardizing data set. Cloud Ingo, cloud-based solution, and IBM InfoSphere quality stage. These are certain tools which are freely available. But first one is the open source. Others maybe you have to pay for certain amount. Okay. Yeah. So I'm about to finishing now. Advantages. I've already told so many advantages. Need not to repeat it again. But yes, for the sake of completion, it helps to increase the accuracy, improve the data quality. Obviously, you will have better analysis, insights, and better data representation. And finally, helps data disadvantage is it time consuming because you have to do a lot of tasks. I told you standardization, normalization, imputation, and removing the unwanted file, noise you have to remove. So all this comes into the picture, but it is time consuming. Error prone can result in a loss in important information during maybe what happened that, for example, I was talking about EEG and ECG. Certain points that when you try to remove those peaks which are correspond to the noise, it happened like your signal can also be lost while removing the noise. So it is error prone, some points, and resource intensive because it requires a lot of time and efforts, obviously. So this is the conclusion and key takeaway points. We talked about both data, how to pre-process, how to cleanse in, and then how this data quality can be improved, how the data collection has been done, primary, secondary, and then how we can have a better insight by cleaning the data. Of course, there are certain pros and cons to the cleansing of the data, but of course, we learned a lot of techniques today. So thank you so much. I'm open for the questions if you have any. We'll stop it.
Sir, one question from me.
Yes, please.
So you mentioned that our range should be between 0 to 1.
Yes,
So
yes.
what is the importance of that? Why we need that our range should be between 0 to 1?
Okay, I'll tell you the example for that. You must have gone through BTech or what was your degree?
It's
What
BTech.
BTech, correct. So did you see that your marks were 0 to 100 only? Why not 0 to 1000?
Oh yeah, because 100 is the maximum percent we can get.
Correct. We can still make it between 0 to 1. Correct? How?
Yeah.
Like, for example, you got 70 marks. I divide by 100. How much you got?
0.7.
0.7. So you can see that my range is reduced, dynamic range. When your dynamic range is reduced, it is easy to visualize. When your dynamic range is large, let's say starting from 1 to 10 to the power of 5, can you analyze such a large range?
Okay, got it. So it's like a percentage only. So
It's
we
a
cannot
percentage
go beyond
only.
100% like that. So
Ah,
percentage itself is 100. So like that,
exactly.
data itself, one is complete 100% data. And
Complete
zero
100%. Absolutely correct. It's just a matter of scaling.
Okay,
You're
got it.
just scaling, but your range is reduced now. Analysis range.
Yes, got it. Thank you.
You don't want that till 10 to the power of 5 numbers. Like you have passed with 9 lakh, instead of 9 lakh, 99,000 marks. You got my
Yes,
point?
yes,
Yeah.
got it. Thank you.
I'll tell you, it's a very bad example, but when I was in Indonesia in 2023, okay, you must have seen their currency is rupiah, RUPIAH, correct? And it was very, very small. Like you take 1 lakh rupiah, it's equivalent to 10 or 100 rupees, something like that. I said, Array, I'm taking 1 lakh rupees. I was worried. Array, I'm taking so much, and if someone stole my money, I will be lost. But then when I saw that the currency change, I said it's 100 rupees or 10 rupees only.
Okay. So it is
Yeah.
just for conversion purpose that our
It's
range.
just, it's just a conversion. Maximum will always be maximum only.
Okay.
It is just a one only. Yeah. Anything else? Yeah. I hope you have enjoyed the session.
Yes.
A lot of insights we have discussed today in about the data, how to handle the data. Yeah. Yeah.
Yes.
Anything else? Yeah. Okay. If there are no more questions, so shall we end?
Yes, sir.
Yes.
Yes.
Okay. See you tomorrow. Okay. 10 a.m. Bye-bye.
Yes. Bye, sir.
Bye. Thank you.
Bye-bye, everyone. Yeah.
Recording stopped.